we're going to be taking a little bit more of a peek here. My apologies for the 7.5 when we're really dealing with 8.6, but you'll see we got the same worksheet working here. So when we go to solve these equations, we're going to use our inverses just like we always do. Now, in the past, basically, that's been add, subtract, multiply, and divide. Well, we just have learned yesterday that there's a little more to it now than that. So we still have those as options, but we also are going to have our couple of inverses that we talked about yesterday, where if you have a log of a certain value, and that value, or it could look something like this, those are inverses and cancel. Okay, so like add, subtract, multiply, and divide would. Okay. We also have e and natural log or natural log and e, depending on which. And again, those are inverses and can cancel. Now, don't scribble those so deeply if you're jotting those down that you can't even tell what they are here in a minute. But we're going to use these in this big word exponentiate that we started talking about yesterday to make this work a little bit easier for us. So, for instance, if we take a peek at number 1, I notice there's a log of base 16 on each side. I need to get that out of the way so I can get to the p's and actually solve this. So we're going to exponentiate with that log value. So we get those in there. The 16 and the log 16 are inverses. So they kind of do opposites and cancel each other out. And all of a sudden, that makes for a pretty good equation for us to be able to solve. Because now I just got to do regular Algebra 1 stuff. So I'm going to get all my p's to one side. I'm going to choose to subtract my 4p over so I can make sure that I get all my p's together. And again, we're trying to get p alone, so we'll add 1 to the other side. Excuse me. And get my answer. Now, one thing I noticed as I work down the page, and I just want to make sure, I know we've said it before, but let's be 100% positive. If I got down to number 3, and we're not going to do it in its entirety, but I want to talk about it for a second, I don't see a number with my log. Like here I see log of 16, log of 13. Okay, what number's here if I don't see one? Hopefully somebody's hollered out at this point 10. Okay, so I'm going to use that when I'm doing my exponentiating process. Just something to keep an eye out for. As we go down a little further, let's see what we got marked up next. Okay, number 6. Again, I have a log here that I want to solve for. So I have to exponentiate with its base, which is 3. Not a problem. We do it to both sides, even though there's not a log over here, just like anything we do with opposites. Whatever I do to one side, I have to do to both. So the 3 and the log 3 are inverses. And here's where I've got to watch it. That's not 3 times 4. Remember, exponentiate. Okay, the base word of that is exponent. So this has become 3 to the 4th power. So 3 times 3 times 3 times 3. And again, if we're not sure on that, go ahead and type it into the calculator and get my answer. Okay. But again, before I can do that, I always have to make sure my log's by itself. You're like, well, yeah, it looks like it is. Yeah. But if I move a little further down the paper, I start to notice that changes once I get to 9, 10, 11, and 12. And we're going to take a look at 12. Now, my first job is to get that log base 7 of n by itself. But I got this negative 7 that's in my way, so how do I fix it? What's the opposite? I've got to plus the 7. So, those guys go. And now it looks a lot like what we did up in number 6. Same concept. So once I have that set, opposite of log base 7 is to exponentiate with my 7. Get that out of there. N is going to be 7 squared. Again, it's an exponent, which is 49. Don't make this harder than it needs to be. Okay, just doing those inverses and opposites, just like we were doing yesterday. So as we head to the back, we're going to jump into another term that we use quite a bit. Now it says solve each equation, and I know what most of you are going to be thinking here. Hopefully you're not too far ahead and have done this already. Some of you are going to say, I'm going to exponentiate with my 2. Good thought, except for one small issue. I can only do each thing once to each side. If I were to... So here's what I'm going to do here to kind of let you see. So don't write this, just kind of watch. If I did my exponentiating here, what happened? I exponentiated twice on this side and only once on this side. Okay, that would be the equivalent of dividing by 2 different things on one side and then dividing by once on the other side. It doesn't work. I can't do it. So when I get to a point like this, if I can ever get that to come off, there we go. If you have multiple logs, we need to condense first. Okay, so this needs to be smashed down into one log. How am I going to do that? Okay, think about it for a second. When we're condensing, what does add become? It becomes multiply. So I'm going to have 3 times x. The other side only has 1 log. There's nothing over there I need to condense. But now it looks more like the problems we were doing on the front. Once I have those condensed into 1 log, now I can exponentiate. Now I can use the 2 to be able to finish that off and get towards my solution. And if you get an answer that doesn't come out nice, that's not the worst thing ever. Okay, if you want to go to the decimal, you can. I'm perfectly happy with you just leaving it in a fractional form. But both would be correct. Okay, so exponentiate first. Ooh, that was almost bad, Harty. Smack myself. Condense first, then exponentiate. Spit it out, yeah. Okay, a couple more down here at the bottom. Then we'll give you some time to play with these and get caught up on some other stuff. Okay, solve each equation, round your answers to the nearest 10,000th. Now, when you think about that, we got tenths, hundredths, thousands, 10,000ths. 4 decimal places. So solve each equation around your answer. So again, we talked about the inverses on the other side. We've been using log in its base. Here, we've got a different one. We've got e. E's natural enemy is natural log, ln. So, natural log and e cancel. So, n is going to be the natural log of 77. So, ln, again, right below log on the left side of your calculator. If you use it, it's on any scientific though, so even if you have a regular, just plain old calculator, you can find it there too. So I got my ln of 77, and we've got 4.3438. Now, just to prove a point, because I talk about this all the time. You're like, I need a graphing calculator to do these. No, you don't. Let me show you something. Okay? Here's Mr. H's phone. This is the regular just calculator function that comes on a phone. I'm going to assume this is true on most Androids too. If you take just your regular calculator and turn it, check me out, okay? Look at this. ln, e, 10 to the x, log. Okay, you have all this stuff. Oops, I got to actually, on this one though, I got to type in the 77 first. Same answer. Okay? So any calculator that you could get regular on Android or, on your other Apple phones, and most of you have them, not all, but most of you, you could do this, and it'd be on a regular calculator as well. So I got one more I want to do. I'm going to go down to 24 here. So when I get down here, again, before you exponentiate, okay, you've got to isolate that term first. So how do I get the minus 4 out of there? What's that opposite? Right, it'd be to add 4. So 9x equals 60. Now, right, I'm going to divide by 9, right? No! Okay, this is not 9 times x. It's 9 to the x power. You're like, okay, so if I can't divide by 9, what can I do? Well, let's flip back over for a second. Okay, if you have a value and its log are inverses, okay, let's flip back over. So the inverse of 9 would be log base 9. And again, whatever I do to one side, I have to do to both. Those are opposites. And so that's what I'm looking at. Now, I can't just leave it that way. I can get an answer. And this we have done plenty. This is where I do my change of base. Log of the of value divided by the log of my base. Or, in other words, log of the number on the right over the log of the little itty bitty number. Log of 60 divided by log of 9. 1.8634. Now, do a good job with this. Finish these off. Make this simple. Okay. Some of you saw in the quiz that if you don't practice, these bite you. Hopefully we've learned a lesson from that. Our next thing, because this is the last of what we're doing new in this unit. So the next couple of days are going to be spent dealing on reviewing for the unit test, which is coming here quickly. So again, get in the practice now so you can feel good when that comes.